Yeah, by the way, I am recording. When I remember to hit record, I'm recording the lectures, and I'm going to start putting them on a YouTube playlist. I think I linked on Canvas to this playlist earlier today, so there should be one video on there for now. This will show up, later today or tomorrow for you guys to view if you want to go back and watch these. So a system of equations is a group of equations with the same variables. Here's an example of two equations and two variables, x plus y equals 2 and x minus y equals 0. And we always are going to indicate a system of equations with this like curly bracket on the left, just to indicate that I'm grouping them together as a system. So that's what this is here. And question you can ask is, what does it mean to solve a system of equations? Now I have more than one equation. What's it mean to solve it? And the answer is that to solve a system of equations is to find a value for the variables, in this case x and y, that when I plug in those values into both equations, I get a solution for both equations. So the values for x and y have to solve both equations. So, for example, over here with this system, if I pick 1 for x and 1 for y, plug it in, you'll notice that it solves both of these equations. So 1 and 1. 1 plus 1 is 2, and 1 minus 1 is 0, right? So 1, 1 is definitely a solution for this system of equations. It solves both equations. And just plug in 1 and 1 for x and y in both of those equations, and it will solve both of them. An example of something that's not a solution would be 2 comma 0. So 2 is for x, and 0 is for y. Well, if I go up to the top equation, I get 2 plus 0 equals 2. That's true. So it solves the first equation, but again, if I plug in 2, 0 for the second equation, I get 2 minus 0 equals 0. But 2 minus 0 is 2, so this is false. This does not solve the second equation. And so, since it only solved one of the two equations, this cannot be a solution of the system. So again, a solution of the system has to solve both equations. Okay, must solve both. Okay. So, in general, this is kind of a dumb system. If you kind of stare at it, we could probably figure out that that was supposed to be the answer here, just by kind of eyeballing it and thinking. But in general, that's kind of hard, and we don't want to have to just guess solutions. We want to have methods for solving for solutions. And so that's exactly what we're going to do next, is how would I solve for a solution to a system if I just give you some system? And so we're going to have a few different methods. I want to talk about 2 of them today. And you'll learn another one on your activity. And then in 5.3, we'll have yet another method for solution. But we'll get to that later. So our first method is what we call substitution. There's a substitution method, and it works like this. The idea is this. We're just going to solve one of the equations for one of the variables. So we're going to solve one of the equations for one of the variables. It doesn't matter which equation you pick or which variable you pick. Doesn't matter. You're free to choose. But we're going to solve one of the equations for one of the variables. And then, and I'll illustrate this with an example, but then we're going to substitute this into the other equation and solve. So I'll solve the one equation for one variable. I'll take whatever I got, substitute it into the other equation, and then solve. And that'll tell me one of the values for the other variable. And then the last thing I would need to do is find the original variable. So telling you this sort of abstractly, it probably isn't that helpful. So let me just illustrate the example. We'll go ahead and just solve this thing again explicitly. We know what the solution should be. It should be 1, 1. Let's find that out explicitly by using substitution. So maybe I'll draw the line. So let's do step one. Let's solve an equation for a variable. It doesn't matter which one we choose. Maybe let's take this first equation up here. Or maybe this, let's take the second equation. It's just going to be a little easier if we take this one. But it shouldn't matter. Let's take this equation here, this x minus y equals 0, and let's solve it for, I don't know, x. Let's get x by itself. So all I'm going to do is take this equation, and I'm going to add y to both sides. So I have x minus y equals 0. And so what I'm going to do is add y to both sides. And what does that give me? Well, that'll just give me x equals y. So if I solve the second equation, I get x equals y. Okay. So I can now substitute this up here into the first equation by just wherever I see x, I could just instead write y. So we're going to take x plus y equals 2 now. And instead of writing x, since x equals y, I can just replace x with y. So I'm going to get y plus y equals 2. Y plus y equals 2. And, well, I can simplify this. That means I have two y's, right? I have y plus y, that's 2y. 2y equals 2. And 2y equals 2 just means that y is equal to 1. And divide both sides by 2. So by substituting x equals y into this equation, I get y equals 1 when I solve it out. Y equals 1. Okay. So we know y equals 1. Now that I know y equals 1, I just have to go back and find out what x is. But notice here I have x equals y. And if y is 1 and x is equal to y, then x is also 1. So I also know that x is equal to 1. So I know my solution is 1 comma 1, which we already knew, but now we found it explicitly. We solved for it using the substitution method. Okay. I'll pause. If anyone has any questions, it's a good time to chime in. So this is our substitution method. Pick an equation and solve for one of the variables in it, substitute the result into the other equation and solve it, and then go back and find that original variable using what you found in step 2. Okay. Probably quickly do. Oh. So this is substitution. Maybe now, yeah. I think what I'll go ahead and do is we'll show the other method now. There's the second method I want to talk about. And then I'll show an example of that, and then maybe we'll stop for questions. And if you guys want, I could either do another example or we could just start our activity. So we'll see how we're feeling after I show you this with the method here. So one method is substitution. The other method is something that your book, I think, calls elimination. I think this goes by different names depending on who you ask. Maybe in J111 or M018, if you took that, it might have been called the addition method or something. I don't know. This might be a more common term, so we'll call it elimination, this next method. And I'm going to show sort of a different example alongside this one. Although I suppose I could do that example again, just to make it clear. X plus 1 equals 2. Well, we'll do this example again, and then maybe I'll do another one afterwards to illustrate something just a little more complicated. How does the elimination method work? Instead of substituting, what we're going to do is sort of add the two equations together. we're going to add the two equations together. And the idea is that we want to do it in such a way that I cancel out one of the variables so that then I have an equation with just one variable instead of two. And then I can solve that equation, and that'll tell me the value of one variable, and then I can go back and find the value of the other variable. So that's what we're going to do. And sort of here's the strategy. Line up the equations so that the variables match by their variables. So we just want to line up the equations so that on top of each other so that the variables are lined up. And so it's already done here. I have the x's are in a column like this. I have the y's are in a column like this. And then I have this just numbers. These constants are also in a column. So I just want to line up the variables. It's just going to make our lives easier so I can do this efficiently. We'll line up the variables. And then once I've done that, if I need to, we'll multiply the equations by numbers. Multiply the equations by numbers so that the coefficients of a variable are opposite. So if I need to, I'm going to multiply the equations by some numbers so that the coefficients, which are just the numbers in front of the variables, have opposite signs, or opposites. So in this example here, it's actually already done for me, perhaps. You can pick any variable you want. If I look at y here, I'll notice that here I have positive y, and down here I have negative y. So these already have opposite signs. So in some sense, I'm already done with step 2 in this example, kind of a dumb example. It's already set up nice for us. These guys already have opposite signs. If I was trying to choose x instead, if I wanted to cancel out the x, notice I have positive x and I have positive x. So I would have to multiply maybe the second equation by -1 to make this into a negative x to get them to be opposites. So in general, that's what we want to do. I want to pick a variable and get the numbers in front of them to be opposites. And the reason we want to do that is because what we're going to do next is we're going to add the two resulting equations. So add the equations. And then solve the new equation. I'm going to add the two equations together. And that's going to give me a new equation where I've canceled one of the variables. And then I'm going to have to solve that new equation. So in this example here, I'm going to take x plus y equals 2, and I'm going to add it to x minus y equals 0. I'm going to add these up. And now you see why we want to add it up, have the variables in columns, is I can now just do x. I can do to like terms. I can do x plus x is 2x. And I have y plus negative y, which is 0. They cancel out because they have the opposite signs. And so there's no y term. I get 0y. And then 2 plus 0 is 2. So the new equation I get is 2x equals 2. And if I were to solve that for x, I would just get x equals 1. Divide both sides of that by 2. So again, we see x is 1. And now the last step of the method, of course, is just find the other variable. So now I just need to find the other variable. And so if I know x is 1, I can just go back to one of these equations and substitute 1 for x and solve. So like x minus y equals 0, that tells me that since I know x is 1, that's 1 minus y equals 0. And that just means that y equals 1. So again, I find that x and y are both 1. That's my solution. So we've now found it by a second method, which was elimination. So any questions here?